the PR out. There's a lot of discussion on it. So there's some major things I want to see if come. Yeah, I want to see if we can bring up discussion. I'll also send the doc in the chat. Like I tried to subscribe to the email list, but it never worked for me for some reason. So
okay, that's strange. Yeah, we can link. Let's link that into the doc also. Okay. Great. So okay. So I guess first on the agenda, I think I covered everybody. If I missed somebody, please speak up. I apologize. So I think first is the 96 stats proposal.
Micah, you want me to share the doc?
Yeah.
Like present it?
Yeah, right. I can present, I guess. Or actually, yeah.
Yeah, go ahead.
Did that work? Yeah, okay. Okay, yeah. Do you want to give some, either Rahul or Alkas, do you want to give some background on this?
Sure. So we have in that 96 physical type, which is deprecated, and it's only used for timestamps emitted from Spark, as far as I know. This type doesn't compare logically if we do bitewise comparisons. So its min and max stats are undefined by the spec. Now, our photon engine in Databricks is actually emitting the logical min max of this type and using it. And we also inspected some other libraries like Parquet Java, RORS, NaroCpp to see what they do with this type. And most of them ignore it. The RORS actually reads it and writes the wrong stats. So we think that we can actually make this, we can add the min and max here without breaking anyone and improve the current state of this type, even though it's deprecated, until Spark manages to switch out of it and completely remove in 96 from Parquet, which is going to take a long time.
Yeah, I think that makes sense.
That's kind of the gist of it. The core of this is that the changes needed are very small. The wording in the spec is mostly, it's just text. We don't need to do anything actually there and just implement it in a couple of places. And we have the PRs, if you scroll down, that are relatively small, if you can see. And I think it's kind of harmless change. That's kind of how we want to present it.
Yeah, so I think there were like 2 outstanding things, and I think you replied today, but and I think Ryan has also reviewed some of these and maybe had some questions. So maybe Ryan, I don't know if you want to go first or.
So my only concern is that we basically use the same approach that we have done in the past and say, look, these stats are reliable from Parquet MR from this version on. I seem to remember writing incorrect stats, years ago. And I don't think that we want to just assume that any Parquet MR version has produced correct stats just because it hasn't produced them in several years. So let's just have something that says, Parquet MR from version 1.10 forward. No, it's not 10. 1.13, 1.14, whatever it is, forward. We trust those stats. And at that point, I don't really have a problem with it. I just want to make sure that we're not creating situations in which we have a correctness bug.
Sorry, Ryan, could you, when you say we, who do you mean by we?
Probably the Parquet community. What statement did I make? Sorry.
People, you're talking about we should only look at statistics after MR or whatever, right? But there's more
Yes.
things that right. There's more Parquet readers and writers out there. And so,
Yeah. So I'm saying the project, right? Like, in order to get this in, what we would need to do is say we're introducing a sort order for int96 that corresponds to int96 as used as a timestamp. We're confident that that is correct because let's face it, int96 has only been used for timestamps, right? So cool. We're happy introducing that sort order and saying if you produce statistics, you should use this sort order, or you should, whatever. And then maybe we either look for that sort order in metadata. I forget if we can do that. Or we look for, writers that are known to produce that particular ordering. And that's the path forward. I think the idea here is legitimate and correct, right? That we know people are still using these for timestamps. So far, like we either have not produced stats or have produced stats that can't be used for timestamps. Let's just fix that.
Does that make sense? Sure.
I think someone on the list proposed the new sort order, and I think that sounded like the correct thing. Although I think that we would love to support Photon specifically, because Photon has been writing these in a way that it can use for a long time.
So I actually think for this type, if we want to dig into the details, the specifying the sort order is kind of the wrong thing, mostly because the type was added as a design word. So the physical type is int96, which only has meaning for timestamps. So there is no logical type that modifies the meaning of this int96. So in principle, the type-defined order of this type is the logical one for timestamps. So we cannot really add anything to whatever already exists.
So the problem is that the type-defined order, I believe, is
It's undefined.
Well,
Today.
Then let's introduce something where we can determine, like, for this file, did we use the ordering that we intend, that we want, or did we use some other ordering? Because the fact that arrow rs produces incorrect stats, right? We need to be able to detect that we have correct stats somehow. And I would love to also make this a change so that we can specify how to correctly produce those stats. That way we can not just do this in Parquet MR, but have a way to detect this was written with int96 stats that sort correctly when the int96 is a timestamp.
Yes. Well, I think the point is we never annotate, if we say it's with a logical type, we never annotate int96 as a timestamp, right? It's just always assumed to be. So I think investing additional metadata overhead and conversion for int96 because it's deprecated is maybe the wrong direction. And I think we can close on this and we just need to make a decision. I think as long as we have proper versioning checks in readers that in writers that decide to implement this, that should be okay. At least in my opinion. I don't know.
I also support the absolute minimum changes to get this in, because it's kind of a legacy thing. The less we add, I think that the better it is.
Yeah, no, I guess. Sorry.
I'm just curious, how much of a legacy thing is it really? I'm very unconvinced by looking at some of the responses and discussions on the Spark list that Spark, like what date is Spark going to stop doing this? And the natural conclusion is like, if they're not going to stop doing it reasonably, and it's such a behemoth in the ecosystem, why don't we just acknowledge that, claim, undeprecate in 96 and just define it correctly?
I cannot really answer that. I mean, there is a push from inside that we want to switch to in96.
Switch away from it.
Switch to in64 as a default, but it's not possible because of customer data and other dependencies that customers have.
Well, it's a lot of work, maybe not possible. Lots of work.
Well, I think there's maybe some really old clients out there. I mean, I think the Databricks question aside, I think it's more a question for like open source Spark. So I think Andrew linked to a pull request to like change the default to in64 for like open source Spark. And I think my main question is like, when will that be merged? Like, does that need to wait till like Spark 5.0 because it's backwards incompatible, or like, will it not be merged even then?
I mean, the reality is, even if it's merged in 5.0, I think it's gonna take more years until we stop writing this thing, completely. So the customers, they're gonna have old versions that are gonna write it. They're even gonna enable it in 5.0 because they have other systems that don't understand in 64 nanos. So it will exist for a while longer, but I don't see the need of undeprecating it because we don't want to promote its use. If it's used because reasons, compatibility, legacy, okay.
Right. To be clear, Spark doesn't write out like nanosay, right? Like I thought Spark's timestamp type was microseconds. It was purely microseconds, and like they're adding a new nanosecond type.
Yeah, the internal representation in Spark is micros from the Unix epoch.
Right, and there's going to be a new type that's nanos, and the nanos will use like the in64 nanos, is my understanding. But it's really like the micros which presents the problem.
Yeah.
So I think there's, so is Spark on like a yearly major release cadence now? I guess I don't know what the cadence is for releases, for like major releases, when a breaking change like this could go in. Does anybody here know? No. Okay.
I don't think it's yearly.
Yeah.
Okay. I think haven't we been trying to, or didn't the Spark 4 release itself take a year to get out?
Yeah. I haven't been.
Yeah, I think it took more than a year from 3 to 4.
Okay. Right. So I think there's, like, in my mind, there's like 2 lead times, right? There's like, we can do this change in Parquet MR, that will probably get picked up in Spark 4. So like in 96 stats will start being written then, but it would really be nice for like Spark 5 to have the change the default to in64 for like micros type.
In 64 nanos.
In64 micros.
Oh, so
yeah,
that is the
the
default.
question is, when is Spark going to be able to use the int64 representation as the default?
Specifically, the non-deprecated version as the default, right? Like,
yeah,
that seems to me to be the core like discord, right? Like we claim this thing's deprecated, and yet now we're basically bending over backwards to support it in the other writers, which suggests to me it's not. Maybe I just have a different understanding of what deprecated means or is supposed to mean.
I mean, it's like, we can deprecate as Parquet community, and then people decide not to for reasons.
Yeah,
people still using Java 8.
Recognize it, right? Like, it's not deprecated. People are going to keep rewriting it basically in perpetuity, is what I'm hearing from this call. So let's just acknowledge that and call it a day.
Well,
this fixed encoding and everything will be fine.
I think like advertising as deprecate is the right thing to do, and I think we want to push on the default change. It just, there's the admission that it will take years before that default gets propagated to Spark because of their versioning.
Why is it the right thing to do, in your opinion?
I think int96 is ill-specified in general, right? Like if we want a wider nanosecond type, we should really consider it from scratch, right? Like the Julian day part in int96 is weird and has like implications for days before the Julian cutoff, which I don't think are well specified, but should be well specified in a type. It's the thing.
If we consider this bending over backwards, then how much do we really want to bend over backwards to make int96 a thing that you can and should use?
Well, I mean,
I don't think that's a good use of our time.
What do you mean can it? I thought all Spark open source uses it. What do you mean it can't use it? It feels like it's already the current situation, right? Maybe I could I update the spec or something and try to clarify, like, even though it's deprecated, it's still widely available. Therefore, it's like, I think it's just confusing to see something that's like deprecated. We certainly ran into the arrow. It's like, oh, we shouldn't care about this.
So like what we mean by deprecation here, I think matters. And that is new implementations should not use this representation because it is needlessly complicated. It has holes where we don't understand behavior and the behavior is unspecified. And we have a very good alternative that can be used for microsecond level timestamps.
Yeah, and
second precision timestamps. So new writers don't use it. New readers probably will have to until the writers actually move over.
Yeah, so I think clarifying that in a note makes sense, and so we can discuss on the mailing list, but I think the open items are like, when can we actually get Spark to stop writing the type by default? I should have an answer for that, and then clarifying that while deprecated, there's lots of writers that still write it and we should use it. I think the situation is probably getting a little bit better because Iceberg, for instance, does not use this type even in Spark, is my understanding.
We allow reading it. But
it's not written, right? And I think that's the point.
Yeah, it is not allowed to be written into the tables. Now, should we, it sounds like what we might want here is to wait until we have an answer back from the Spark community on when we can expect Spark to change the default. If we have that, then would that be more satisfying? That way we can at least put some parameters on like how long this is expected to last.
Sorry, one question there. Even if they say it's going to be in 5, we will still want to go through with this change, right? So even the earliest it comes in 5.0, even then we will have to like improve the situations for the existing.
So we, and in this case, I'm using we to mean Databricks. We are coming to the Parquet community and saying, please do work. Please consider this new sort order for a deprecated type in order to support something where, we still want it to be deprecated, but we're not going to say when we'll stop using it. Like, I think it's reasonable for the community, those of us who don't work for Databricks, to say, well, what is going on with this? When are we going to fix Spark?
Sure. I'm wondering here, what will change? Do we have something in mind? So if the answer is never, would we not do it? If the answer is very soon, how will change how the community acts?
Ask for clarity on this, and I think it'd be better if we knew when this would happen. But
that's independent of this change, right? That's what I was trying to say. Like with this change, we will move forward or not move forward independent of that answer.
I don't know. I mean, it's up to people in this community to say, yeah, we're willing to move forward with this, even though we have no idea when Spark is, really going to stop.
Okay. In my opinion, it's a perfectly fine change. I would just like to, this is not the first time I've been confused about 96 timestamps, and it's just annoying, right? Like if they're going to be around with us forever, we shouldn't be pretending like they're not. And so then, I don't know. So that's my beef with it, but that's a different opinion maybe.
Yeah, right. So I think that's also a perfectly valid thing. I think we spent a bunch of time on this. I don't know that we have that much more to cover. Unless somebody wants to add it, maybe we should move on to next agenda items. Yes. Okay. Andrew.
I just wanted to give somewhat of a propaganda excitement about how great we're doing with Parquet variant in Rust. Mostly we have, we started the implementation of it. We have a team of like people from CMU and Databricks, and I don't even know where everyone else is from Pydantic, whatever. We're all cranking on it. So it's all just doing great. It's basically the message. And I had one fallout of that as I try to articulate the process of moving it up through Parquet and then eventually getting into like Data Fusion. Do we have a timeline on the formalization, like the logical type annotations in Parquet actually not being draft?
I think we need a second implementation before they're not draft. So if Rust gets there, that's great.
Well, the C++ one has the annotations in it, right? Like Neil merged that.
Sorry, I think there's a distinction here between the annotations being valid and adopting the actual spec, right?
Yes.
Because we can say like, hey, and on the Iceberg side, we could really use a release that allows us to annotate the variant data that we're capable of writing. So I would love to see a release that says, yes, you can, annotate the data, so we can do the cross language testing. Like right now, we still can't produce data files that are annotated so that another project can actually read them as variant. So I'd love to see at least us stand behind the annotations and say this is how you label the data, even if we intend to, or we think we might change the actual spec. Although I'm honestly, like at this point, I'm not sure how we would change the spec.
Yeah, but I think it's still like, as a formality, we want the two implementations. I thought we released I thought we ended up doing a release. Did that not happen? I thought there was some consensus on doing.
So there was to get a release of Parquet format. And so we're using Parquet format in Parquet Java, but we don't have a Parquet Java release. I'm also I'm reviewing, and I think we're just waiting on fixing some test failures on the Parquet Java side before we have an implementation that can read and write shredded data.
Yeah.
We're working on the writers right now.
Yeah, so I mean, it might be a good. Yeah, I think we're into Q2, and so it might be good to do a Java release once that's merged, so we at least have some compatibility tests. And then, but I think the second implementation is the blocker for the full format. It's no longer experimental.
Yeah, we haven't hit any blockers yet. Like everything's working fine. We're just working through it. Every time you see the spec, like this is not yet finalized, right? Like a big warning on it. So
So how close to having everything working on the Rust side are you guys? Because
I'd say within a month-ish of having the ability to read and write it into, well, I'm already doing what I always tell them. I'm not going to speculate, but like we're relatively close to having basic support reading and writing, but we're nowhere near like shredding and then full integration into Data Fusion, because part of that's we have to sort out how to integrate it with Arrow too, which I think basically people know, but that still needs to happen as well.
Yeah.
So like I admit it's going to be a couple more months before we're ready to, but I don't know what the threshold is to say we've got implementation.
I mean, so what we're doing in Parquet Java is the ability to basically reconstruct a equivalent variant from shredded data, or take a variant and shred it into a Parquet schema and get it back. So
did you have to figure the writer like shred these specific fields? Is that how it works?
Yeah, and what our tests are doing is basically we have on the write path, we have a list of variants, and we go and we have a test where you write it unshredded and get it back and verify it's exactly the same. Basically that you get the same encoded value back. We have a test where you shred it using a schema that corresponds perfectly to the actual data value, and that you get it back correctly. And then we have a test that uses a shredding schema from one of those values and writes every other value into that shredding schema and reads it back so that, you can say, if I have 2 records that, share 2 fields, but not all fields, that you get the same thing back. That's basically what our tests do today. And those are shared across, we use the same test cases in both Parquet Java and in Iceberg. So like, I think that those do a good job of validating that you can take basically any variant and shred it into any shredding schema and get the same variant back out.
That makes sense.
So from, at least on the CMU side, we would be thrilled if those particular Parquet MR test cases could be just exalted somewhere of, this is the core set of things we would like to see with shredding, and this is the behavior that we want it to be. And ideally, if we could have like sample files attached to that we could use for a verification target, that'd be amazing for us.
The tests produce sample files, and as part of the test, you could just easily go extract them. But they also, like everything, uses, basically we have reader tests that exercise the write path by saying, like, by writing essentially Avro records that correspond exactly to the shredded data, and then reading them back as a variant, right? So that's our read test. We write just regular records, and then we read them as a shredded variant and verify that the variant is what we expect. So like, you can absolutely take all those tests and run with them. MR is released, I don't think that we can produce like the data files. But we could definitely produce, like we could take those tests and basically, I think produce a, like, here's a binary file that corresponds to the one, record in this. That would be pretty easy.
Yeah,
you want me to point you guys to the tests?
Like, when you're familiar with all the code, I'm sure it's really easy, but like, if you told me to go figure out how to get the, like, basically hook into the test and write the intermediate results to files, I bet that would take you a lot less time than it would me. So I don't know if there's any way to help accelerate that process. Like, I'm having to make PRs and stuff, but
I mean, I can see if David has the time to do that. Again, I think that requires a Parquet Java release before we want to start, like, saying, hey, these files, right? Like, we want to release the code that produces the files before we say those files are like our canonical test cases.
Well, we put variant examples in Parquet testing without a release. I think
I don't think that's a blocker. I mean, I think like, if you can write the files, I mean, the idea is that, like, we want to be able to verify these things, and if we come up with different results in a different implementation, that's probably an indication that maybe we're not ready for the Java release.
I'm just saying that the Java release, right? Like, the release process is getting at least 3 PMC members to sign off and say, yeah, this release looks correct. So, like, so far, I wrote the the Iceberg implementation. I'm doing the reviews of the variant encoding and variant shredding pieces in Parquet Java. I mean, if you want my thumbs up on something, I can definitely give it, but I think it would be nice to get a release of the Parquet Java implementation out where people actually are taking a look at this area. That's my only point. That, like, let's get more people looking at the area, validating that we think these test cases are representative and correct. And, to me, the way to do that is a Parquet Java release. Then we say, okay, these are the files produced by a Parquet Java release, and that is, a reasonable test case. We can certainly get you the files earlier. It's just that, our process as an ASF community is we have PMC members take a look at releases.
Yeah, that's why I was trying to dissociate the example files from releases, because, I mean, we're like, we can mark them as like they're not finally official or whatever too. I think that's totally cool. It's just I'll write a ticket and try to follow up in writing about how helpful it would be.
Anything else on variant, or we can maybe move on?
No, it's going good so far. I'm very excited. It's good.
Deck float.
Yeah, so I'm sending the deck float proposal in the chat. So, but the basic summary is that last time in the May 28th thing, Thomas proposed this decimal floating new types to the Parquet as a logical type. So we've had a great discussion that time, and also received a lot of feedback. We are working on to refining the proposal to adding more details. So today, I just want to continue some discussions last time mentioning about some alternative options, especially the one we call the extension types. So we did some search and we found like there's one like a draft PR containing the spec for the extension types. I just want to follow up in the communities. So is that like the latest status of that extension types? And so everything inside that should be like the latest status we can refer to when considering as an option.
Yeah, that's the latest status. Like Antoine started that, and he did not have bandwidth to kind of drive it as a proposal fully. But I don't think there's any objections in principle to extension types. It just requires implementation.
I see. So what we like take from that spec, our understanding is that for the extension type, it means that the vendor or the third party writes some like specification of that particular type they want their Parquet to support, and they add that to the Parquet metadata, and then the third party or the vendor should provide the reader and writer that really understand those particular extension type names, so that their reader and writer can read the Parquet file with those extensions. While other readers, for example, the official readers in the Parquet Java, they can understand this extension logical type, but they do not have like more custom implementation. Will only read the physical representation, and that might not be like contain useful information if we specify like too many rules in terms of the type encoding and the computation.
Yeah, I think the intent I think that's right. Like, so in other places that have extension type, like arrow is an example, there's two different types of like extension types. One is extension types are flexible, so people that don't want to drive consensus around how these things are read will go ahead and implement their own extension types, and to some extent, or want to drive consensus outside the community. So for some extent, like GeoParquet is an example of this that could have used extension type. They just find metadata around Parquet, but it could have been an extension type if that existed. And then there's notion of more canonical extension types, where you kind of want to say, here's what we are doing and the way of encoding this extension type, and sharing that around. And so I think an example of that in Arrow is like tensor types and variants are actually being implemented in Arrow as an extension type. So it's not, and those would live in official Arrow implementations. I think something similar makes sense for Parquet. So like if there's a canonical extension type of deck float, it means implementations could decide to read it as like the logic for reading it could be put into like specific implementations, and like there's a shared understanding there. It's just lighter weight than adding a new logical type to the core spec.
I see. So is that even if like the new type is probably like added as an extension type, but the detailed implementation could still reside in the in the open source repo somewhere, for example, in the Java.
Yeah, I think that. Yeah, that certainly makes it. Like, I mean, I think there's some process stuff to work out, but I think that's the intent. It doesn't force the implementation to be outside of like the like Parquet's open source, like Parquet's repos.
Thanks. That's really helpful to know. And just like quick follow-up question. So do we also consider this extension type to be like a POC or experimental way for the types that laterly we want to standardize into the format?
I think that's an open question. Yeah, like yeah, that's some of the process stuff, right? Like I think once you have an extension type and it kind of has agreement between a few repos, I'm not sure what the exact like. There's certainly some bits making an official type, but there's also like, if enough people have consensus on it, then it de facto becomes an official type. But yeah, like it certainly could be a good way for people to, like, I mean, one of the reasons is like it can be a good way for people to experiment with things and have like the right hooks, and then come back to the community saying, we've done some experimentations and like we'd like to add this as an official type.
Cool. Thank you so much. Yeah, so we will definitely take this into consideration and update our appendix to include this as like the alternative option discussion. So just also like a quick question about how we typically move forward with a new type addition. So do you think at this stage, maybe in the future, we can a draft PR would be a better place to discuss more details, as what we propose for this spec, or do you think like maybe we can just continue to discuss in this Google Doc? What is like the most preferred way in the Parquet community to do that?
I think a draft PR makes a little bit more sense. Like once we narrow it down on like what we want to build, I think the Google Docs, like this is my opinion only, and other people should chime in. But I think the like there's a couple of open design questions, and like once we define like this is the preferred approach, then like starting to make draft PRs makes
more sense.
Makes more sense.
Okay, thanks. Yeah, I will. So we will continue work to like refining the proposal, and so just finally just call for more eyes on this proposal one. So everyone, if you have any opinion about this new decimal floating data types, please feel free to add comments in the doc.
Yeah, like at least from my perspective, I think the main open question in my mind is like how it's actually encoded, like whether 18 byte, like just like fixed length 18 bytes, I'm not sure is the best way. It might turn out it's the best way just because of the nature of the type, but it seems like you could potentially shred it, which raises like a different problem in Parquet in terms of you can't have stats on like non-leaf fields, and so it becomes a question of like how you work around those, like how you potentially work around that.
Yeah, I think that's definitely a very good question. We're actually like working on to see if we can like have a more detailed design for this part. So probably like next time we can have like a more detailed discussion once we have that out.
Yeah, cool. Anything else on DeckFloat?
Yeah, that would be all for my side today. Yeah.
Sorry, Martin, did you want to say something?
Yeah, just a comment. Julian brought up a fantastic point when Thomas was originally presenting, which was this idea of building out a floating point format with however many bits and what fields, and making implementation choices that make sense for the application. Because for something like this, the implementation part is going to be a lot more straightforward than all the procedural components, where this proposal is very targeted towards what you're looking for to get out of this. And so your the unusual bit length and the choice to not support infinity and NaN values is very particular to your own applications. And so it's almost more of an uphill battle to say, hey, everyone could benefit from a type like this, rather than we want something that we can have as an extension type that we're using on our own. And so like the procedural crossing is going to be almost like going back to the 70s, 80s, when everyone was hammering out IEEE 754 and everything else. So I think I would be super on board with having all this effort focused specifically on the extension type part. And then if DeckFloat becomes a very widely used extension type, everyone loves supporting it, then you can make the decision to canonize it after the fact. but you already have a demonstrated interest and everyone's using it at that point, and it's not just a very specific implementation. So that kind of gets over those procedural hurdles with an actual proof of people are using this. As it's almost like the choice of some of the choices in this document could almost bring up like tribal disagreements and how to represent a numeric type. So that was my concern back then, and I'll repeat it now. Mostly because I absolutely love extension types to become more standardized, as that gives the research community a ton of open tools to really try out stuff within Parquet. So we'd love that, but our 2 cents.
Thanks. That's a really good point. I think, I think from I recall like last time we also made some more discussions around like adding those parameters to make this type like configurable. So but I understand in general we want like a more probably like in the first stage like a more flexible framework. Yeah, we're also considering that. So that is also part of the reason that I want to like learn more details about the extension types, because like it allows you to specify arbitrary numbers of parameters you want in this extension type, so we can be configurable in that also. Yeah, we will also take this into considerations, and hopefully we can get a more detailed proposal next time, so we can have more discussion.
Okay. Interval type.
Well, I don't know if Yun is still here. But yeah, I mean, we have a lot of discussion that's happening so far. I think one of the main questions that's come up right now is compatibility with arrow types and the arrow month, day, nano, which, yeah, I know, Micah, you've chimed in. A lot of folks in this meeting have had some comments. So I was wondering what the general feelings are of folks after what's been said so far.
I need to catch up. I mean, I think from my perspective, I don't think like the zero copy to arrow is all that important. Like we're adding these types for like a very, we're proposing adding these types for a very specific reason, and I think arrow made some different design choices for intervals, and so like. But I don't think I had the strongest objections here, right? I think people who like felt very strongly about this were Matt and David, who are looking for something stronger. And then I think the other objections were around kind of naming and like how the naming is either misleading or doesn't align with arrow types, and that's something I think is potentially easier to resolve, so we can name things better and then just say. Like we can go either way, right? Like we can name it according to SQL standards, or we can say this is actually this type, and like if you want to store daytime at like the SQL take daytime, we recommend using this this type. I think that those are maybe easier conversations. I think we probably need to maybe send out like a separate email with and just like move forward with a decision on like the arrow compatibility stuff once like we get caught up on the naming things. I'm not sure if David or Matt like had any concrete suggestions on how to move.
Yeah, I think someone made the point that the zero copy is basically not going to happen with any kind of encoding in the way, so we should probably not really block on that.
Yeah, if that point's been met, right. So I think we should have like clear rationale here. I mean, I think there are some other questions like, is like a 16, should we be storing this as fixed length 16 at all? Like it seems like we can probably get away with a shorter type, except for Oracle, which seems to do something, wants to be able to have a range in the heat death of the universe type thing.
Yeah.
So like some of those minor things, like we should probably close on and have at least a rationale for why we chose, 16 bytes, where I think a lot of the bits are going to be wasted at the storage level. Then And
Yeah, I mean that makes sense to me. Like if we're not actually doing a longer integer type that we want to define, if we're just doing a fixed length byte array, probably is not as big a deal. Although I feel like the coders still have to do a lot of work there, but I don't know.
Yeah, I think we should just like examine that space a little bit more. I think it is an interesting question of like, do we want to try to formalize an 128 type in Parquet? And I think in the future that would be more useful, but you can just as easily say this is a logical type that corresponds to 128 once that exists, and like retract.
So many good jokes about what we screwed up with in 96 here. Do we really expect anything other than crazy values to be like 16 bytes? Because to me, that's what we should be looking at here. We don't need a sentinel value that is, all bits set to 1. Really, let's think of a reasonable way to store these things. So do we really need 16 bytes?
So if we want to cover, the widest range that I think for engines like Oracle and Snowflake want to represent, we need at least 10 bytes. So the next aligned one is 16. If we go shorter, then the precision will have to drop. If we still use the total number of nanoseconds, the fixed array is still the total number of nanoseconds.
So, the way that we think about it, we being Databricks, has been engines can have wider types than necessarily we need to store. I don't know if that makes a big difference here, but like how often are we actually trying to store these sentinel values that are that require 10 bytes?
So my only question here would be, because we've had a couple of questions here also on precision. If we did want to allow picosecond precision, 16 bytes would probably be good if we wanted a parameterized type where they're all the same length. And that's, I don't know, this is me kind of going down the path of, do we end up with a 128-bit int type anyway? And if we do, then it's all kind of matches. Otherwise, I have no problem using a smaller fixed length byte array. But that would mean if we ever do want to have picosecond intervals, and then we have to do something, again, different.
I agree with you there. Like the choice of, are we moving to define the picosecond precision types? And if so, we're probably going to use an int 128. If we're not, though, then a 16 or even 10 byte value here means that we can represent a larger value in an interval than we can in a timestamp.
But I mean, we'll probably go in that direction eventually, I would think.
Yeah, I mean, eventually, I think it's a question of. Yep, Alkis, go ahead.
Can we, I haven't read this proposal in detail, but could we say the interval type is a fixed length byte array of 1 to 16 bytes, and we store it big endian, and the reader will fill in the top bytes with 0 if they're up to 16, and then the engine can do whatever. In most cases, we'll store 8 bytes because that's enough. The natural byte order sorting will work, and we satisfy everyone, even the fringe cases. Does it make sense?
I'm not familiar with the history of doing multiple type lengths in Parquet. Is this something we've been able to do before?
It's not multiple, it's one, but the writer decides, and when it is going to write one Parquet file and it sees that all my intervals they fit in 8 bytes, it will just write in 64s. Pretty much.
what we've done in the past is parameterized by type. So the precedent that we have here, other than variant, which is a little odd on its own, the precedent that we have is decimal. And when your decimal precision goes above, what fits in an int or a long, we upgrade that type. So there's nothing data dependent on it. It is type dependent. We also have a number of issues just with the way the library works. If we wanted to go and change physical representation after you create the reader, we were looking at I looked into this briefly for variant shredding to see like, hey, can we get actual data values and determine the shredding type based on what we've seen so far, and like add columns and things like that dynamically? Does not work well. So we could probably, it was encryption that made that not work. We could probably like re-encode the entire column, but then we'd have to find some way to bubble up that we changed the physical type of something. I'm not sure that this is a great path forward. I would say, like, if we know that our nanosecond timestamps are, using an int64, we probably don't need a larger type for intervals. And if and when we do introduce a decimal 128, then you can choose to use that not decimal 128, int 128. We can choose to use that as a valid representation for these logical types. To me, that's the most logical path forward, is use int64 today because we can get this functionality out and it fits most of the use cases. If and when we introduce decimal int 128, then allow all these types to use the wider form.
Yeah, I think there's some debate, and fortunately I have to drop off also on like, is long sufficient, right? Like, and how important is that extra range according to the SQL standard? Like, I think a lot of these go away a lot of the arguments go away if we say, having more than 200 years in an interval type for time day is even if the SQL standard says it's not a real use case.
I mean, it's perfectly reasonable for us to say, we need a wider type, let's go define int 128. I would fully support that if that's where we want to go. I probably wouldn't support the half step of like, well, let's just have a 10-byte decimal value, or sorry, 10-byte value that, and then try to shred differently, or like, if we want wider types, let's just define the wider int types.
Yeah, well, I mean, shred differently. I like, for interval types, you aren't shredding, right? Like, it's really.
I'm saying I probably would not pursue Alkis's suggestion here, which is like, when the data values require it, use 10 bytes, but normally store it in an int64.
Right. Like, I think that makes sense. I'll try to capture that in notes. I'm sorry, I have to drop off. I think.
Yeah, I do too. Thanks, guys.